multiplying a binomial with a trinomial. Lesson 8.5. You're watching this video with Ms.Y. Cavazos. So in the previous videos, we had been multiplying two binomials. Well, now we're going to step it up a notch. We're going to do a binomial times a trinomial. Okay. Now there's two methods from all the three methods that you learned. There's only two that we're going to be able to use. And I'll explain to you why out of the three, only two work and why that other one doesn't work. So the first method we're going to do is the distributive property. Now as you remember, distributive property said we're going to use this term and we're going to multiply it with the second binomial. Well, we're going to do the same thing, except now it's a trinomial. Then we're going to multiply the second term by the second binomial, but in this case it's a trinomial. It's very doable. So we're going to go ahead and start with that. Okay, so we have 6x times this entire trinomial, so 2x squared minus 3x minus 5. Then we have a plus 5 that we're going to multiply times the same trinomial, 2x squared minus 3x minus 5. Okay, so we start off, of course, by using the distributive property. 6 times 2 is 12. X times x squared, though, x to the power of 3. Okay, and in case you forgot, we got to remember that we're doing x times x squared. When this occurs, same powers, we're going to keep the base at the exponents, hence that's where the power of 3 comes from. Okay, continue with our distribution here. 6 times negative 3, negative 18, x times x, x squared. Then we move on to the next one. 6x times negative 5, negative 30x. Now if you think about it, this process, you've done it before when multiplying polynomials. 5 times 2 is a positive 10x squared. 5 times negative 3 is a negative 15x. 5 times negative 5 is a negative 25. We look at what we have and you realize, oh my goodness, this is a really long polynomial. And you're right, it's long. The best thing to do is to have it in standard form with the like terms next to each other. So we look here, this is the highest degree, so we're going to start with the 12x cubed. Then we move on to the next set of like terms, which would be our x squared. Then we move on to the next set of like terms, which is the x term. So I'm going to put them in that order. Negative 18x squared with a positive 10x squared. Then it's the 30x with a minus 15x and then a minus 25. You've done this before. Then you realize that you could combine those. You could also combine those to give us our simplified answer. So we begin with 12x cubed. Negative 18 plus 10 is negative 8x squared. Negative 30 minus 15, type it into a calculator, and that gives us a negative 45x. Bring down the minus 25, and that is our simplified, beautiful, long polynomial. Our simplified expression. So let's try another example. Again, we're going to take this binomial times a trinomial and we're going to use the distributive method, which allows us to break this up into two sections. So 3x times the trinomial, 2x squared minus 4x plus 5. And then we have plus 2 times the same trinomial. Next we multiply. 3 times 2 is 6, x times x squared, x to the power of 3. Next we have 3 times negative 4, negative 12, x times x, x to the power of 2, or x squared. Then we have 3x times 5 would give us a positive 15x. Then we continue with this one. 2 times 2 is a positive 4 with the x squared. 2 times negative 4, negative 8x. 2 times 5, positive 10. Now, some of you have been able to easily identify the like terms. We notice, oh, there they are. So we can rewrite it, or we can start off with the highest degree. In our minds, already know that this term and this term are going to go together, and that is negative 12 plus 4 would give us a negative 8 x squared. And then again, some of you already know that these two are going to end up next to each other. You just got to be careful that you got to understand that this is a 15 with the minus 8, and that would give us a positive 7x. We bring down the 10, and this would be our simplified answer. Again, I skipped a step just because some of you understand how these two like terms come together to give you a combined term. Others, I would encourage you to do the next step, which is the commutative property, so that later you can apply the associative property and then simplify to this answer. So that's one way. The other way is using the box method. We can surely use that method for this problem. Of course, the box would have to look a little different. So we have a binomial times a trinomial. So that means 2 rows with 3 columns. So that means 6x would go here plus 5. 2x squared goes here minus 3x minus 5. And just like we did with the binomial times a binomial, in order for us to fill these in, we're simply multiplying according to the box that we're trying to fill in. So if I was trying to fill in these two boxes, then I would multiply those two terms. And you understand, so on and so forth. So first we begin with this first box, or rectangle, however you want to think of it. And we have 2x squared times 6x. 6 times 2 is 12. X times x squared, x to the power of 3. Then I'm going to move down to the box below. 5 times 2x squared is a positive 10x squared. Then the next one, 6x times negative 3x would give us a negative 18x squared. Then I'm going to do this one, negative 5 times 6x, negative 30x. 5 times negative 3 would give us a negative 15x. And lastly, we have negative 5 times 5, which would give us a negative 25. Okay, what's so beautiful about the box method, remember, is that if you look diagonally, there's your like terms, and guess what? There's your other pair of like terms. So we start writing with the highest degree. We are aware that we're going to need to combine those two. So 10 minus 8 would give us a negative 8x squared. Then we will need to combine those two. Negative 15 minus 30, which would give us a negative 45x. And then at the end we have the minus 25. By the way, this example is like the first example I went over in this video. I'm just trying to show you that there's another way of doing it. So this would be the same simplified answer that we got on the problem a few minutes ago. Let's try another one. This second problem is the second problem that we did using the distributive property method. But of course, I want you to understand that we can apply the box method here. So we use 3x here, minus 5. Then we use 2x squared plus 7x minus 8. Now we fill in the areas. So 2 times x squared will give us a 6x squared. Oop. Actually, no, a 6x cubed. Sorry about that. Next, I'm going to do 2x squared times negative 5 would give us a negative 10x squared. Then we have 7x times 3x would give us a positive 21x squared. Then we have negative 5 times 7x would give us a negative 35x. 3x times negative 8, negative 24x. Lastly, negative 5 times negative 8. Two negatives multiply to give you a positive. 8 times 5 is just 40. Again, if you pay attention to the way all of this turned out, we notice that our like terms are right here, diagonally. Right here, diagonally. So when we write our final answer, we start off with the highest exponent, the highest degree. We combine those two. Negative 10 plus 21 would give us a positive 11x. Then, of course, we would combine these two in the calculator, and that would give us a minus 59. Okay, let me start again, because I kind of did my mistake here. We start off with the highest degree, and that is an x to the power of 3. Then we combine negative 10 plus 21, and that gives us a positive 11x squared. Then we combine the negative 35 with the minus 24, and that gives us a negative 59x, and then finally we have our 40. It is in standard form. We have the highest power, and as you can see, it's in descending order. This is our simplified answer. And I was wrong, this is not an example that we did. This one's slightly different. So I hope this helps you understand. Actually, I'm not done yet. Let me explain why the FOIL method wouldn't work with these here. So remember, FOIL stands for first, so we would multiply this. This would be our F. O stands for the two outer ones, so this outer times this outer. I stands for inner, so these two inner terms would multiply. And then L stands for last, so this one times this one. So as you can see, you could kind of do FOIL method, but then what happens to this number? This number has to get multiplied by the two terms. So FOIL doesn't work for this problem. So I wouldn't attempt to try and do it. Make up your own arrows. No, no, no. Don't even try. Just stick to the box method or distributive method and you'll be fine. Thank you for watching.